please write arc length and area of a sector. Arc length and area of a sector. Now a sector is like a piece of a pie or a slice of a pizza. Some people think it looks like a triangle, and it does have 3 sides, but this portion right here is rounded. These two lengths are exactly the same length. We're going to refer to them as R. I'll tell you why a little bit later. And it's rounded on the outside, and we have this theta, or this central angle, on the inside. Now this comes from an entire circle. This is the center of the circle, and I wish I could draw a nice circle, but that's one piece of a pie, okay? And we call it a sector. So we're going to figure out what is the area sector. We're also going to figure out what is the arc length. And if we think of it in terms of a piece of pizza, it's the crust, it's the outside portion. This is your arc length on one piece of pizza, and then the area is in the inside. Now here are the 2 formulas that you need to have memorized. First is arc length. The arc length is written as S equals R times theta. And I'm going to draw a piece of pizza here. These two will always be the exact same length. This is your central angle. And we use an S to represent the arc length or the crust. Now, fairly easy to do. The one thing is a lot of times they give you a central angle in terms of degrees. Like they say this is 30 degrees. This central angle has to always be in terms of radians. So if they tell you in degrees, first switch to radians. So here's our first problem. We're going to be told that we have a radius of 8 inches, and we have a central angle that is equal to 68 degrees. What is the length of the arc on a sector that has a radius of 8, this is 8 and this is 8, and this inside angle is 68. So to figure that out, we're going to write this formula down. S equals R, which is 8, times, not 68, we have to convert 68 into radians. So remember to do that, you're going to take 68 on a calculator, you're going to divide it by 180, then we're going to reduce the fraction by hitting math fraction, enter, enter. And we're going to attach a pi symbol. So 17 over 45 pi. This will give us what is the length of the arc on this sector. So let's figure it out. Ready? We're going to multiply the top. Please take 8 times 17 times pi. Use the pi symbol in the calculator. Do not use 3.14. Then we're going to divide it by 45. And let's round this to the nearest tenth. So 9.5. Now we're talking about a length here, so 9.5 inches. Okay, 15 seconds. Check with your partner to make sure that they understand, please. Go ahead. Okay, your next one is going to be the area of a sector. So we'll give you a different sector. This one has a radius of 4 inches, a radius of 4 inches, and an interior angle that is equivalent to 40 degrees. And we want to figure out what is the area of this. So think of this here. We got a slice of pie here. This is 4, this is 4, this is 40 degrees, and we want to know what is the entire area of this. So to do that, we use the formula that you need to have memorized, 1/2 r squared times theta. And just like with the previous type of problems, theta, that central angle, always has to be in terms of radians before you can actually do the work. So 1/2 times, okay, the radius is 4. 4 squared is 16. I can't plug in 40. First I have to put it into radians. 40 divided by 180. Let's reduce that fraction and then attach a pi symbol. So I'm going to plug this in now. I have 1 times 16 is 16, and 16 times 2 is 32, and then I have 32 times pi. So let's go 32 times pi in the numerator, and we're going to divide it by 2 times 9, which is 18. I'm going to round to the nearest tenth to get approximately 5.6. 5.6 square inches. Remember, you can also use this symbol as well, inches squared. I'm just going to make sure that I did my math there right. This times 16 times that is correct. Area, square inches, or inches squared. Check in with your partner before we go on to the third type of a problem for today. Make sure your partner understands. Make sure your phone's put away so I don't have to keep it until tomorrow, please. Thank you. Joseph, you want a new partner? Okay, your next one. Okay, a circle. We're going to actually use it from the PowerPoint, the exact one. So give me 1 second here. I'll pull this up here. Okay, this one, please write this down. A circle has a circumference of 16 pi and an arc length of 356 pi over 45. What is the central angle of the arc in degrees? Okay, the circumference is 16 pi, and the arc length is 356 pi over 45. So how do we do this? We want to know what is the central angle. So let's first draw this, and think of this in terms of a big picture. This is the center of the circle. Okay, we don't know the central angle. In fact, we don't know the radius even of this, but we know the entire circle has a circumference of. So circumference is 2 pi r. Let's set that equal to 16 pi. We're going to solve for the only variable they show us, which is r. Divide both sides by 2 pi, and r is now equal to 8. So I know that the radius of this circle is 8. So I'm going to put 8 in this place and 8 in this place. The problem also said that for this particular sector, it has an arc length of 356 pi over, was it 45? So as a reminder, the formula for arc length is S equals R times theta. There's 3 different variables. You already know this one. You know this one. And this is ultimately what you want to find. You want to find what is the central angle, and you need to convert it back into degrees. So let's write 356 pi over 45 is equal to 8 times theta. To eliminate the 8, you definitely could divide. You could also think of it as multiplying by 1/8, whatever works for you. If you want to think of it as multiplying times 1/8, then please take 45 times 8 for me. And 360, can you check my work? Yes? Okay, so this is the central angle, not in a reduced form, but this is the central angle in terms of radians. Convert this at this time to degrees. Go. You may use your partner for help. So as a reminder how to convert it, we're going to take 356 divided by 360, and then we're going to take that times 180. We've detached the pi symbol, and now we're going to add a degree symbol to this. How many you were able to come up with 178 degrees? Hands high. Would anybody like me to go over that with you? Not a big deal. Okay, here we go. Grab the calculator. So, to convert from radians to degrees, forget about this radian measurement. Please take 356 divided by 360. 356 divided by 360, enter. And now take it times 180 degrees. We've detached the pi symbol, and now we're going to attach a degree symbol. Do you end up with 178? With a degree symbol. Okay, we're going to go on to the third problem. We're going to do a softball problem next. Here we go. Have one person in your group please read it. So there's some things we need to know here. They want to know what is this, and I'm going to call this the home run fence. That's the fence they're talking about. Does everybody see how it's yellow here? They want to know what is this length. We know that this length is 200. We know that this length is 200. And this angle here, this interior angle, is 90 degrees. So please draw that sector. Okay, so I know this is 200 feet, and I know this is 200 feet. This interior angle is 90 degrees, and we don't know what this is. So two things we want to do. Let's find the length of this fence, also known as the arc length of this problem. And then afterwards, let's also find the area of this field. So arc length is S equals R times theta. Your R, already given, is 200. And they already give us this angle, it's 90 degrees, but if I put 90 in there, it'll be wrong. I have to convert it to radians. To do that, please take 90, divide it by 180, hit math, bless you, math fraction, enter to reduce the fraction and attach a pi symbol to it. Okay, so let's do this. Let's take 200 times 1 pi, enter, and divide it by 2. 200 times 1 pi, and then divide it by 2. And let's round it to the nearest foot, so approximately 314 feet. That is the length, this is the length of the fence, 314 feet in the outfield. For the area of this sector, which is the softball field, we're going to use the formula A equals 1/2 R squared theta. So 1/2 times 200 squared, again not 90, but we use 1 pi over 2. Let's see if you can plug it in and get the answer. Round it to the nearest foot. Go ahead. I have approximately 31,416 feet squared. Does anybody want me to help you with the calculator to get that? No problem, it won't take long. Yes? Okay, here we go. You ready? Take 0.5 times 200 squared, enter. 0.5 times 200 squared, enter. Got it? Then take it times 1 pi, enter. Remember to use pi, not 3.14, and then divide it by 2. Same answer? Good to go. All right, we're going to go on to your